Okay, so dark matter. You know, we talk about it like we know what it is, but do we? I mean, it's this huge invisible thing shaping the whole universe, and we're basically guessing. And now there's this thing going on at the center of the Milky Way, and it's got me thinking. It started with this article, right, about ionized gas in the central molecular zone. CMZ, they call it. Sounds like some kind of sci-fi battleground, doesn't it? Anyway, there's way more ionized gas there than we'd expect. Like way more, and the usual explanations, they just don't cut it. So here's the crazy part. Maybe it's dark matter, but not just any dark matter. This lighter, self-annihilating dark matter, like when two particles meet, poof, they disappear, leaving behind electrons and positrons. It's like a tiny cosmic explosion, right in the heart of our galaxy. Just a moment, let me take a deep breath. Wait, think about it. If dark matter clumps together at the center of galaxies, like we think it does, then these annihilations would happen more often there, and these electrons and positrons, they'd have enough energy to rip electrons off atoms. Ionization, that's what they're seeing. It's like a puzzle piece clicking into place, or maybe it's just wishful thinking. I mean, we're talking about a particle lighter than a proton. That's tiny, and it's not just floating around, it's interacting chemically with the universe. We've been so focused on gravity, haven't we? Pulling, bending, shaping, but what if dark matter is also changing things? Now, this is a bit of a side thought. It's funny, we spend so much time looking out at the big picture, the galaxies, the cosmos, but maybe the answers are right here in the tiny interactions, the subtle shifts. It's like we're looking for a giant monster, but it's actually a swarm of invisible insects changing everything one bite at a time. So let's get back to the article. Shyam Balaji, this researcher, he said it best. Unlike most dark matter candidates, which are often studied through their gravitational effects, this form of dark matter might reveal itself by ionizing gas, essentially stripping electrons from atoms in the CMZ. Essentially stripping electrons, think about that. We're not talking about some abstract force anymore. We're talking about actual physical interactions, tiny but powerful. Guys out. And then it hit me. And it's not just about the CMZ, is it? If this is true, if dark matter can ionize gas, then it's affecting cosmic chemistry everywhere. The whole universe, we've been overlooking this subtle chemical effect, and it could change everything we know about how the cosmos works. So let me ask you, what if we've been looking at the wrong things? What if the key to understanding dark matter isn't in massive gravitational effects, but in these tiny, subtle chemical reactions? Let's break this down further. The central molecular zone, a region roughly 500 light years across, is incredibly dense with gas and dust.
Yeah.
The sheer quantity of ionized gas found there is perplexing. Standard models, which primarily consider ultraviolet radiation from stars and cosmic rays, struggle to account for the observed levels. To truly understand the implication of this, we need to consider the scale. 500 light years is a vast distance, and to have that much ionization throughout such a large area requires a significant and consistent energy source. Now imagine these dark matter particles constantly annihilating each other. The resulting electrons and positrons, due to their high energy, could then collide with neutral atoms, specifically hydrogen, which is abundant in the CMZ. These collisions would transfer energy enough to knock off the electrons, creating ionized hydrogen. This process, repeated countless times by the sheer number of dark matter interactions, could explain the observed ionization levels. Furthermore, the lightness of these proposed dark matter particles is crucial. Most dark matter candidates are theorized to be massive, weakly interacting particles, WIMP. However, if these particles are significantly lighter, they could interact more frequently, leading to more frequent annihilations and thus more ionization. This change in frequency would also have a measurable effect on the energy released. A larger amount of lower mass annihilations could release an energy signature that is different from the theoretical signatures of a smaller number of higher mass annihilation events. Moreover, the process of ionization is not just a simple electron removal. It triggers a cascade of secondary reactions. When an electron is ejected, it can collide with other atoms, causing further ionization or excitation. This creates a chain reaction, amplifying the initial energy input from the dark matter annihilations. Therefore, Even a seemingly small number of dark matter interactions could lead to a significant overall ionization effect. Finally, consider the implications for our understanding of galaxy formation and evolution. The CMZ is a crucial region for star formation, and the ionization state of the gas directly affects the formation of new stars. If dark matter is indeed influencing this process, it could have profound implications for how galaxies evolve over time. It's like a tiny, invisible hand shaping the very birth of stars. So yeah, dark matter, it's still a mystery, but maybe, just maybe, we're starting to see it in a whole new light. And maybe, just maybe, it's not just pulling things together, it's also changing them. What do you think?